Today's lecture, we're going to talk about symmetry for equations in two variable. So here we I've picked three types of symmetry that we have to discuss. One is symmetry about the y-axis, then the other one is symmetry about the x-axis, and finally symmetry about the origin, about the center. In the first case, symmetry about the y-axis means if you pick any point on the graph, on a given equation, if you pick a point on a graph exactly across the y-axis, on the other side, the same point belongs to the graph. So here, if you look at the coordinates of these 2 points, what do you see is this point has coordinate of x, y. What is the coordinate of the other point? The y value is the same. This is the x value that is just the opposite, so minus x and y. So if you're checking for a symmetry about the y-axis, so symmetry about the y-axis, what you need to do is let x replace x with negative x. Let me actually pick a different color here. Replace x with negative x in the original equation. And check to see if you get the same equation. This is what we would do. We would replace x with negative x, see if we get the same equation. If that happens, that means both the points x and y and the point negative x and y, they both belong to the equation. It means the equation is symmetric about the y-axis. How about symmetry about the x-axis? Very similar. If I have symmetry about the x-axis, any points that I pick on the graph exactly on the other side around the x-axis, so the x values are fixed. It is only the y values are the opposite. This one is y, the other one is negative y. So the coordinate here is x, y, and you would have x and negative y. Okay, so just to check symmetry about x-axis, what we do is we replace y with negative y in the original equation. By doing that, if we get the same equation, after simplifying you get the same equation, that means that both 2 points x, y and x and negative y belong to the graph. Therefore, the graph is symmetric about the x-axis. How about the origin? If you look at the origin case, symmetry about the origin, if you pick a point on the graph and say it's symmetric about the origin, that means exactly reflected on the other side should be a point which has the same x and y. This is x and y. On the other side, it should be exactly the same x value but opposite sign, exactly the same y value, opposite sign. So if the point x and y belongs to the graph, therefore the point negative x and negative y must belong to the graph as well. So if we're discussing symmetry about origin, then what we need to do is we replace x with negative x, and at the same time we replace y with negative y into the equation to see if we get the same equation as well or not. Here, let's do a couple of examples. Maybe do examples of each. Example. Y minus x squared equal to 2. Let's say you're given this equation and they ask you, check if it's symmetric about x-axis, check for symmetry. If you can graph the equation, it's much easier to discuss it, but it would be more work. So here what I'm going to do, I'm going to check through all three cases. Is it symmetric about the x-axis? Is it symmetric about the y-axis or origin? So here first, let's try x-axis. Then we try y-axis. And finally, we will try origin. What do we do for symmetry about the x-axis? If you forget it, just go back, draw a line, draw this picture, and say, if I want to have symmetry about the x-axis, what do I need to do is I should have the same x value but opposite y values. That means change the y from positive y to negative y into the equation. See if you get the same equation. If I do that, what do I get is negative y minus x squared equals 2. I'm replacing y with negative y. And compare these two. Is it the same equation? Can I simplify it? Not really. There is no more simplification. So the answer is no, because now y has turned into negative y. So it's not symmetric about the x-axis. How about symmetry about the y-axis? For symmetry about the y-axis, we replace x with negative x. So what you get is y minus negative x squared, don't forget the squared, equals 2. And can you simplify it a bit? You can, negative x squared means negative x times negative x becomes x squared, which equals to 2. Now compare this with the original equation. Is that the same equation? Yes, it is. This is the same as y minus x squared equal to 2. So what does it tell me? It tells me that the graph is symmetric about the y-axis. So there is a symmetry here. Symmetric about y-axis. How about the origin? Is it symmetric about the origin? You can try to replace both. So here I'm going to replace negative y and at the same time replace negative x for x. And simplify it. Negative y, I cannot do anything with that. Negative x squared means negative x times negative x. Turns out to be positive x squared equals 2. Is this the same as the original equation? And the answer is no, because this guy has negative. So not symmetric about the origin. About origin. So we only have one symmetry in this case, and it's a symmetry about the y-axis. And if you look at this graph, what is it? This equation is basically y equals x squared plus 2. This is what the equation is if you move this. And this is a graph of a parabola. If you look at the first example, it will look like something like this. From 2, this would be the graph. X squared shifted up 2 units. And you would see that there is only symmetry about the y-axis. Okay, let's try one more example. Here, what if we have x squared plus y squared plus, let me change it to minus, equal 4. Do you remember what this equation represents? If you remember, this is the equation of a circle with the center 0, 0, center is 0, 0, and radius square root of 4, which is 2. And how does it look like? This is 0, radius 2, you would have a circle. This is the graph. Is it symmetric about x, y, and origin? The answer is yes to all three. But if you don't remember it, you don't remember how to graph it, you can go through those processes. So I'm going to go through the process and check, and I expect yes for all three cases. So here, x-axis, symmetry. Replace y with negative y. I'll have x squared plus negative y squared equals 4. If you simplify, you'll get x squared plus negative y squared. It turns out to be y squared equals 4. Same equation. So I have symmetry about the x-axis. If you replace x with negative x, this is just check for symmetry about the y-axis. You'll get negative x squared plus y squared equals 4. and then x turns into x squared plus y squared equal to 4. Again, this is just simplifying that equation. This is the same as the original equation, so I have symmetry about the y-axis as well. And again, you can look at the graph and see it, but how about the origin? Replace x with negative x. So negative x squared plus replace y with negative y squared equals 4. So what do you get? Simplify x squared plus y squared equals 4. Same equation. So I have symmetry about the origin as well. If you knew that the graph already, you didn't need to go through this, but sometimes it's not easy to graph a function or an equation. Okay. I hope these were good enough examples. There are a bunch more examples you can pick from the textbook. So now let's discuss a specific type of function, which we call it the piecewise function, because it's depending on pieces of different functions combined together. So here is an example of a piecewise function. F of x equals to, there are two equations. One is x plus 2, the other one is square root of x. But the restriction, here are the restrictions. It says if x is less than 1, then you use this equation. If x is greater than or equal to 1, use the square root of x equation. So what I'm going to do is, let's try to calculate maybe if they ask you to find out what is f of 0. What you do is first ask yourself, what is the x value? X in this case is the input given already, 0. So x is 0. Which inequality is it going to satisfy? Is it going to be in this section or in the other section? 0 is less than 1. So therefore, I should use the equation x plus 2 and replace 0 there. So what do I get? I get 0 plus 2, which is 2. So f of 0 is basically 2. That means if you have x value of 0, y value must be 2. How about if we want to try f of 3? Let me change it to, yeah, why not? F of 3. Then 3 is now bigger than 1, so it belongs to this section. So what do? I use the square root of x equation. So I'll say this is square root of 3, and that is the y value. So x equals to 3, y must be square root of 3. Okay. How about if I ask you what is f of 1? What would be the answer? The answer is, you look at the equation, which one of these 1 belong to? Does 1 belong to x less than 1, or does it belong to 1 greater than or equal to 1? So in this case, 1 is greater than or equal to 1 because you have the option of equality. If there was no option of equality, then you couldn't pick either one. You would say this is undefined. But in this case, since we have the equality sign, I have the square root of 1 as the function. And what do we get is 1. So I have the point 1 and 1 belong to the graph. Okay, so if you want to graph this function, let's discuss the graphing at the same time as well. So if you want to graph this function, what do? Let's say, let's pick a couple of points. I'm going to show you through points, then we can discuss it, since we already know how these graphs look like. X, Y. Let's pick a couple of points. Negative 1, 0, 1, 2, 3, 4. How about that? I think this is good enough, but I'm going to pick a 9 here as well, just because there is square root. Okay, let's find their y values. What are the corresponding y values? Negative 1. Where does it go? It's an input. It's less than 1. So I use the equation of x plus 2. So negative 1 plus 2. How about 0? 0 is less than 1. So therefore, I use the equation x plus 2. So I will have 0 plus 2. How about 1? As we discussed, 1 does not belong to the top equation. It belongs to the square root because you have the equality option. So you'll get square root of 1. Same, square root of 2, square root of 3, square root of 4, and square root of 9. And if you simplify, this is 1, 2, again 1, root 2, root 3, 2, and 3. And I wanted to ignore the root 2 and root 3 because these are decimal values. That's why I didn't really want to use these guys. So what do I have? I have a bunch of points here. What are those points? Let's find them. -1 and 1. -1 for x, 1 for y. 0 and 2. I have 0 and 2. That's the other point. I have 1 and 1. 1 and 1. I have 4 and 2. Okay, this is 4 somewhere here. And 2. And then we have 9 and 3. I'm going to pick this. Okay. If I would have asked you to graph these functions separately, x plus 2 would have been a straight line. I'm going to draw this. And it would have been going through these 2 points. This would have been x plus 2. Because it's a straight line with the slope of 1 and y-intercept 0, 2. We could have graphed that already. And the other one is square root of x. Square root of x would start from here, and it will look like that. Okay. So now, what is the piecewise function? Piecewise function in this case tells you that you cannot use all that. You can only use up to a specific location. That means if x is greater than 1, you use the square root of x. So that means if x is less than 1, you're not allowed to use that. So the graph stops at this point. You cannot continue, go below 1. And on the other side, the same. It says if x is less than 1, you can use this function, x plus 2. If it's bigger, then that's not an option. So you cut off the graph up to the point x equal to 1. Okay, so here is something that you should be careful. This point here at the end is exactly at 1. If I pick both points to be closed circle, that means the post point belong to the function. And what do you get at the end? You have 2 points on the same vertical line. So this is not supposed to be a function. But if you remember, if you look at the equation, you have x less than 1. You do not have the option to pick 1 on the straight line. So what you do is you make this an open circle. Say, okay, at this end point, I'm not allowed to pick 1. I'm allowed to pick any other point less than that, but I'm not allowed to pick 1. 1 for what? 1 for x. And for the square root, you're allowed to pick 1. So the 1 is closed circle. What you can do is you can graph each function separately, so you don't really basically do not need all these points if you know how to graph them. But if you know the points, it would be helpful. So you can graph the function for each section. Say, okay, this is a square root. I'll graph the function. The other line is a straight line. I graph them. And then apply the restriction. X less than 1, I should have a straight line. So this is 1. Everything on the left side should be a straight line. So in this section, have a straight line. And x greater than 1, whatever this is, x is greater than 1. This must be the square root function. Let me go back. Okay, so this is graphing a piecewise function. Now you see that there are 2 pieces of different functions together. That's why we call it a piecewise function. Let's try one more example. Let me shift this up a bit. There's a 3 left at the end. Okay. So now let's calculate. They ask you to calculate f of 0, for example. What would be f of 0? 0 goes into one of these equations. Figure out which one satisfies the equation. I'm going to pick the one that 0 belongs to. X's input is 0. 0 is less than or equal to 0? Yes, it is. So I'm going to use this equation, x squared. What do? I replace 0 for it, because x is given 0, so 0 squared. What do you get is 0. It means the point 0, 0 belongs to graph. How about f of 1? X is given 1. This is your x input. 1 satisfies, 1 is not less than or equal to 0. No. 1 is between 0 and 3. Yes, it is. So I'm going to use the second equation and say, okay, I have 1 minus 2, which is negative 1. F of negative 2. Negative 2 satisfies which equation? Is negative 2 less than or equal to 0? Yes, it is. So I'm going to use again the x squared equation. If it's a function, it should satisfy only one of those inequalities. Otherwise, you will have two different y values. So I'll get negative 2 squared, therefore it is 4. And f of maybe 4. What do you get for f of 4? 4 is not less than 0. 4 is not between 0 and 3. 4 is greater than 3. So what do I get? I use this equation, negative 2x plus 10. Replace 4 for it. Negative 2 times 4 plus 10. And what does that simplify to? Negative 2 times 4 plus 10 is positive 2. It's negative 8 plus 10, positive 2. Okay, one more example. F of 3. Where is f of 3? 3 belongs to which equation? It's not less than 0, so it's between one of these two equations. Which one does it belong to? Since I have the equality sign, here, that means 3 only allows to be in this section, in this function. So I replace 3 there. 3 minus 2 will get to 1. So f of 3 must be 1. And now, what I'm gonna do is I'm gonna graph these functions separately and show you how to connect them. So here, let's try to graph each function separately. You should know how to graph these already. How does x squared look like? This is x squared. So this is the x squared function. How does x minus 2 looks like? This is y equal to x squared. Y equal x minus 2. This is y equal to x minus 2 is a y-intercept form of a straight line. So this is negative 1, negative 2. That's the y-intercept point. And slope is coefficient of x, 1. So 1 up, 1 right. You'll end up at this point. I'll have that. This would be the graph. You can pick more points, by the way. It's important to figure out the x-intercept as well. I'm going to do that as we graph it, but I'm going to give you a structure of how the graph looks like. And how about the other one, negative 2x plus 10? That's another straight line. Y equal negative 2x plus 10. Y-intercept is at 10. So let's say this is 10. Negative 2x plus 10, its slope is negative 2. So you move 1 unit right, 2 unit down. From this point, you will have a straight line down. You should be able to figure out what this point is as well. Where does the function equal to 0 for y? Where is y 0 is x must be 5. So this must be 5. And the same, you can do this here. This must be 2. If you're to get y equal to 0, x must be 2. 2 minus 2. That's how you would find the x and y intercept. It's normally useful to graph the straight lines. Okay. So what I'm going to do is I'm going to apply these restrictions. First restriction, sorry about that. First restriction is x less than or equal to 0. And the graph was x squared. So if this is 0, x less than 0 means everything on the left side. That's what I want. So that means I want this part of the graph. I do not need the right hand side. So I'm going to erase the right hand side. It's not necessary. It's only the left side that I need. And then x minus 2, the other equation, it says from 0 to 3. So 0 for x, this is 0 for x. Where is 3? If this is 2, 3 is somewhere here. Can I find the y value of it? What is the y value at 3? Let me stretch this line a bit more. Okay. What is the y value at 3? Y value at 3, I want to figure out what this y value is. You replace 3 into the function. 3 minus 2, you'll get 1. So I'm replacing into the equation to see what the y value is. We already did that. F of 3 turns out to be 1. So at 3, I have 1. And the restriction is all the x's from 0 to 3. This section. Therefore, x from 0 to 3. This is only the part of the graph that I want. So that part belongs to this section. So anything else outside, I do not really need it. These are not necessary. Oh. Let me draw this line back. Okay. You can figure out what this point is as well. 0, replace 0 for x, you'll get negative 2. Okay. How about the other line? Where is the restriction? All the x is greater than 3. So figure out where 3 is. Let's find out where 3 is. Let's say 3 is somewhere here. I want all the x is greater than 3. So it means I want this section of the graph. How do I find the y value of 3? Replace 3 into the equation. Negative 2 times 3 is negative 6 plus 10. You'll get 4. So this would be 4 for the y values. This point. So I do not need anything less than 3. It's not about the y values, it's about the x values. The restrictions are applying on the x values. This is the part of the graph that I want. So now put all these pieces together. Let me move this a bit to the right hand side. Okay. Okay, so this was the 3 pieces. So let's put these pieces together. I'm gonna draw a bigger picture if possible. Okay. X less than 0, we use this x parabola, x squared form. This is x squared, and up to 0. Is 0 included? 0 is nothing. 0 is included because you have the equality sign here for 0. So it means at 0, you should have a closed circle. Y value is 0 as well, 0 and 0. How about the next one? X minus 2. It's the next straight line. So x minus 2 straight line is at 3 and 1. And the other one is at negative 2. 0 and negative 2. So I'll connect these points. That's the other straight line. That's this middle section. Okay, so now what you need to apply is this properties of the inequalities. You have a strict inequality on the left side and equal, not a strict case. You'll have the option to equality at 3. So at 3 I have the option of the equality, so I use a closed circle. At 0 on the other side, I do not have this equality option. So this must be an open circle at the end. At negative 2, you should put an open circle. That means you're not allowed to pick 0 and negative 2 as a point on the graph. Otherwise, the graph would not be a function. You would have 2 different y values for the point 0. How about the next section? The next section is if x is greater than 3, so 3 and above. What do I pick? I pick this straight line. Where are the points? The point is at 3. I have 4. 3 and 4. And you can pick one more point, in this case 5 and 0. Good enough. So I draw a line going through that. Something like that. And now again, check the inequality. You have a strict inequality. X is greater than 3. So 3, you're not allowed to pick closed circle. It should be an open circle. That means the function at 3 has only one y value. What is that y value? That y value is exactly 1. It's not 4. You cannot pick 4. So at 3, if they ask you what is f of 3, you should say it is 1. Okay. This is how you put the pieces together. I hope it is clear. And based on the graph, you can check to see, did we satisfy these properties? F of 0, was it 0? Yes, it is 0, because that's a closed point. If you put this one closed point, then you have two y values, 0 and -2. And that is not possible to have two y values. F of 1, is it -1? At 1, somewhere here is 1, you should have y value of -1. That's the point. F of -2 is 4. Here is -2. Is it 4? Sure. Somewhere here. I didn't graph it correctly, but I hope it is clear. Okay. Oh, one more topic to talk about, odd and even functions. We're going to discuss odd and even function, which is related to the symmetry. What is an odd function and even function? First, we're going to talk about functions. So, which one of these three are possible to be a graph of a function? This one is possible because every vertical line crosses at most once. The other one, the middle one, it's not possible because now you have 2 points with the same x value. So this is not a function. Not a function. And the right-hand side, every vertical line crosses once. So this one is a function as well. So there is a symmetry property that we cannot discuss. And what is that symmetry property? You cannot discuss x-axis symmetry for a function. It was possible for an equation, but not for a function. For a function, you have only two types of symmetry. Either it's symmetric about the y-axis, or it's symmetric about the origin. There is a third case that it's not symmetric at all. If I have a function that looks like this, it's not symmetric at all about any point. It's not symmetric about the x-axis, neither origin, not y-axis or origin. So therefore, it's not symmetric at all. But if there is a symmetry, it should be one of these two cases. Either it's symmetric about the y-axis, or it's symmetric about the origin. And we already have discussed how do you figure out if it's symmetric about the origin or y-axis. What did we do for y-axis? We replaced x with -x. We replaced x with -x and we saw, okay, do we get the same y values? If we get the same y values, then you have the symmetry. So here is definition for an even function. If you have symmetry about the y-axis, we call it an even function. That means if you replace x with -x, do you get the same y values? If that happens, then you're talking about an even function. How about an odd function? Odd function is if you replace x with -x, I have, let's say this is x, on the other side I pick -x. What happens to the y value is y values are also changing. From negative turns out to be positive. So if I replace x with -x, does y value gets multiplied by a negative sign? If that happens, then we have a symmetry about the origin. That's what we call it, an odd function. So we say a function is even if you have symmetry about the y-axis. Function is odd if you have symmetry about origin. And the notation using the function form is that you can change it to x and y by replacing f with y and use the symmetry about x, origin or y-axis. But normally we use the function notation. So here let's try to see f of x, for example, given f of x equals x squared plus 2. And they ask you, is f even or odd? So what do you calculate? You need to calculate f of -x to see what happens if I replace -x for x. What you get is -x squared plus 2. Can you simplify it? You can simplify it a bit. -x squared is the same as x squared plus 2. So now compare. What is the relation of f of negative x with f of x? Are they the same thing? X plus 2. This is f of x. And what is f of negative x? F of negative x is, it turned out to be x plus 2 as well. So these two are equal to each other. What does it tell me? It tells me that the function is even. You don't need to check for odd anymore. If the function is even, it's not possible to be an odd function anymore. Well, there is one case that even an odd happens if you're taking the function to be exactly 0. If that's the case, then you only have the x-axis. That's the only time that you will get a even and odd function at the same time. So let's assume that's not the case. Let's try another one. F of x is given x cubed minus x. And they ask you, is f even or odd? We want to check to see, is it even or odd? Let's try that. Even or odd, or neither. Sometimes it's neither. Okay. So what do I need to calculate? I'll calculate f of negative x. Replace negative x for x every time you see x. Minus negative x. What do you get? If you simplify it, you'll get negative x multiplied by itself 3 times. It's the same as negative x cubed. And negative x becomes plus x. Okay. Now, so f of negative x simplified to negative x cubed plus x. Now you should ask yourself this question. Is it f of x equal to f of negative x? Because if this happens, then I have an even function. This is the question. Is this one equal to the original function? And you'll just, by comparing, you'll see that the answer is no. This is not true. So it's not an even function. So how about the other case? Is f of negative x equal to negative f of x? That means if you multiply a negative sign to the function f, do you get the same as f of negative x? F of negative x was negative x cubed plus x. This is f of negative x. If I multiply a negative sign to f of x, which is x cubed minus 3, do I get the left hand side? And if you distribute, you'll see exactly these two are equal. This is a true statement. So what does it tell me? It tells me the function is an odd function. So you just check for these two. If it's not true for either one, then you can say it's a neither case. Let me show you an example of that as well. Example. F of x equals x cubed plus x squared plus 1 or something like that. And they ask you to see if it's odd or even. Again, you always need to figure out what is f of negative x first. Place negative x cubed plus negative x squared plus 1. Simplify it. What does it end up? It becomes negative x cubed. Negative x squared turns out to be plus x squared. Negative x times negative x is positive x squared. And plus 1. Okay. Now you do the check to see which case is it. Is f of, so you check these two. Is f of x equals to f of negative x? Or is f of negative x equals to negative f of x? I need to check these two. This is the symmetry about the y-axis and symmetry about the origin. F of x is x cubed plus x squared plus 1. Is it equal to negative x cubed plus x squared plus 1? The answer is not really, because this one is plus and here you have a minus. The answer is no. It's not an even function, so not even. How about if we try for odd function? What do you see is f of negative x is negative x cubed plus x squared plus 1. This is what we have. How about f of x? F of x is x cubed plus x squared plus 1. If I multiply a negative sign to it, are these two equal to each other? And the answer would be no, because negative times x cubed would give you negative x cubed. This is the correct part, but negative times x squared will give you negative x squared and minus 1. Now if you compare, you do not see equality. These two are not equal. This is good, but the x squared plus 1, and here you would have negative x squared. So not odd either. So this is a neither case. It's not odd or even. Okay, why do we call it odd or even is just because of the exponents. If you look at the first example, here is some information. If you look at this, what type of exponent do you have? You have an even number. That created an even function. If you look at the second example, these are exponents, both odd exponents. By the way, here this last term 2 has x to the power 0 next to it. 0 is even. If you consider the second example, we had 3 and 1 as the exponents for polynomials, so that's why it became an odd function. That's why the names odd and even came from. And if you look at the last example, here is x to the power 3, that's an odd number. Here x to the power 2, even. So it cannot be odd or even. It shouldn't be either case. Okay. But that's only for polynomials. Generally, you have to go through this process. I hope that is clear as well. So let's discuss this very last topic, finding increasing and decreasing interval, local max and minimum, given the graph of a function. This is a very easy topic just because you're given the graph. If you're not given the graph, maybe a bit more difficult. Okay, so let's assume you're given this graph. I already draw a couple of graphs, so we have more time to discuss it than drawing. Okay, so let's say you're given these two graphs, and they ask you what is the increasing and decreasing interval. First, what does it mean? It means figure out where the function is going upward or coming down, increasing in the sense that the y value is getting larger, and where the y value is decreasing, where the y value is getting smaller. So I'm going to use increasing. I'm going to use highlight yellow to show the increasing section. Where is it increasing? At this part, this is the function is decreasing, so increasing here, at this section, the y value is getting larger and larger as we go along the curve up to that point. As well as in this section, this is where the graph is increasing. The y values are getting larger. And where is it decreasing? It decreases in these two sections. The y values are getting smaller. The y values are getting smaller, as well as in this section. Right, so in each of these sections, the y values, as you go along the curve, the y value gets smaller. So what I'm going to do is, they ask you to write it as an interval notation, decreasing interval. What does it mean as an interval notation? That means, tell me where are the x section for increasing. So here, increasing section. It means correspond to the yellow part of the graph. What is this x value? This area is where the x value belongs, and the same here. And let's assume this graph goes on forever. So it means you cover all this line. If they wanted to stop there, you should put a closed point there, just to say it stops there. But let's assume the graph is keep going. So that means it continues forever increasing. Okay. So what is the increasing interval? The increasing interval would be the corresponding x values. So the x values from -2 to -1/2. If you look at this section from -2 to -1/2, if the x is in between there, then the y value is increasing. And on the other side is, if it's from 2 to positive infinity, 2 to positive infinity, then the y value is increasing as well. How about decreasing? Decreasing, it's the highlighted, the blues highlighted. It's this section, as well as this section, plus this area. I should have used a different color instead of red again. So it would be from negative infinity to negative 3, all this area. This is where the graph is decreasing, getting smaller as you go on. Then again, from negative 3 to 2, I go to right. You're always moving in the positive direction. So if I move toward the right side, so what happens to the y values? The y values get smaller. So I have decreasing from negative 3 to negative 2 as well. And then from 1/2, negative 1/2 to 2, negative 1/2 to 2. This is where the graph is decreasing. Sometimes the graph is constant. I'm going to show you in the next example, but in this case, you're looking at only increasing and decreasing. Okay, so here, let's look at this example to discuss decreasing and increasing. Where is it decreasing? Where is it increasing? So I'm going to use highlighted yellow for increasing. Increasing in this section. Y values are getting larger, as well as in this section. Let's assume this is a straight line, a flat line. And how about, sorry, let me use a highlighted blue. Decreasing in this section. What about this middle part? Okay. I'm going to pick a different color. There. How about this section? This is what we call the constant. So we have a third option. Sometimes the y value does not change. The y value stays fixed. So let me show you. Increasing interval, decreasing interval, and constant. The increasing interval, where is the increasing interval? Y value is changing. Y value is changing. X value is changing from negative infinity to negative 2, as well as from negative 1 to 0. These are the correspond to the graph. I'm looking at the x values. I do not care about the y values. So I will say from negative infinity to negative 2 and from negative 1 to 0. Sometimes they use close brackets. I'm going to use open parentheses because the endpoint does not really matter. How about decreasing? Decreasing was this highlighted yellowish section. Bluish. So I'm going to say decreasing from 0 to 4. Go back to black marker. From 0 to 4. And why did I stop from 4? Because the graph does not continue. You see, they put a closed circle at the end. That means the graph is only in this section. It doesn't go on forever. If they continue like that, then sure, you say from 0 to positive infinity. How about constant? Constant is the red section where the y value is fixed. It's always 2. The constant is in this middle part from negative 2 to negative 1. This is where the function is constant. It's an interval from negative 2 to negative 1. All those x values. Okay, so this is the increasing and decreasing. It shouldn't be difficult based on the graph. And there's one more thing that we want to discuss. Local maximum and minimum. Local maximum and minimum means if you look at the section of the graph, you don't need to look at the whole graph. If you only pick a small area of that graph. For example, if you pick this area. Is that point the smallest y value? Or is it the largest y value? If that happens, you call that point to be a minimum or maximum locally in that small area. It's not going to be the smallest y value because here you would have 2 and here you would have 0. So that is not the smallest overall, what we call it the absolute maximum or absolute minimum. It's a local max or min because in that local section, in this small area, that's the smallest y value possible. So local maximum and minimum is basically looking at a small portion of the graph and you decide, is there a local maximum? And you always have this shape of either a V shape or like that, you will have maximum and minimum. Sometimes the graph is disconnected, like this case here. Then in that points, you have to be careful to say, is there a local max or min? Okay, let me maybe erase this highlighted section down here. too many highlights. Okay, maybe I went a bit too far. Okay, so let's consider this is the graph. Okay, the highlights are just from the increasing and decreasing. Let's ignore those. Let's assume this is the graph. And we want to discuss local maximum and minimum. This point is on the x-axis. And now, if I ask you, where is the local maximum? Local max. That means what points have this structure that they're the highest y value? If you look at the graph, this point here has the biggest y value. Is there any other points? You cannot pick this point because this keep going. On the right side, it's not going to be the largest. How about this point? Where here's the problem. That is an open circle. So it means that point does not belong to the graph to discuss it. This is not possible. So there is no other local maximum. There is only one local maximum. What is the coordinate? It is -1/2 for x and 4 for y. If they ask you for the local max value, that means they want only the y value. If they ask you for the x coordinate, you only provide the -1/2. If they ask you for a point, you write this as a point format. How about local minimum? Okay, now for local minimum, if you look at these points, let me change this to a different color, maybe green. This point here is the smallest y value in this small neighborhood, as well as this point, as well as this point. So now I have 3 points. Can I consider this one? Yes, I can, because it's still the smallest along this small area around it. So that would be possible, and it belongs to the graph. So I will have 3 points. What are those coordinates? Let me call this -3, by the way. What are the coordinates? It is -3 for x and 0 for y. Y value is 0. And the other local maximum happens at -2 and 0. And finally, we have this point, this one, as well as the other point, 2 and 2. Those are the only local maximum and local minimum. Okay, so the points that do not belong to the graph, you cannot pick them. If this was a closed circle, sure, it would have been a local maximum, but your function, your graph would not satisfy it as a function, because you would have 2 different y values at this point. Okay. All right, if we look at this example and you look for local maximum and minimum, is this a local maximum or minimum? If you look at the graph, this is simply a local min. I'm going to say 0.4 and 0 is a local minimum. How about local maximum? That point, 0 and 3. How about this point? Is that a local maximum or local minimum? Not really. This belongs to this section where it's a constant value. So you cannot consider it as a local maximum or minimum. Some textbook you assume, okay, this is the smallest along this line, so I can still consider. But to me, that doesn't count as a local maximum or local minimum, because on the left side, you have the same y values. So if you consider this point to be a local minimum, all the points along this curve, on this straight line, should be considered as a local minimum. In this case, we do not consider that as a local minimum because the y values are the same. So I'm not going to consider that point as a local minimum. How about this point? Same. It has the same y value as all these point neighbors. So how about local maximum? There is only one, 0 and 3. How about local minimum? 4 and 0. If the graph was continuing along this way, then there wouldn't be any local minimum at all. It would be only one local maximum. It means that not always you have local max and local mean. It is possible that you have neither one as well. If you have a straight line that goes on forever, this has no local max or local mean. But if you're dealing with a quadratic function, remember, you create a local minimum, which is the vertex point. Okay, I think this is clear enough. And I'm going to stop here.